Okay, so number 9. This says show that the triangles are similar. Okay, we have 2 ways showing that triangles are similar. You can use the AA postulate, you can use the side-side postulate, or you can use side, angle, side. Okay, now which of these is going to work in this case? So, unfortunately, we know absolutely nothing about the lengths of the sides. There's no numbers here which gives us the length of the sides. So it looks like these two are not going to work because they need sides. So we're going to have to go with AA. So this is a decision you're going to have to make on the test, is which of the postulates that you can use. So let's take these apart. Let's call this E over here. That didn't come off right. So we have E, B, A, and we have E, C, D. Okay, hope you can see where this is going. So here, E and E are the same. So by the reflexive property, we can say that angle E, okay, is congruent to angle E, and we have our first angle. Now we need to find a second one. So these little arrows here are going to provide us with a hint. So these 2 little arrows means that A, B, and C, D are parallel. So remember, with our parallel lines, we can make it easy on ourselves. Okay, and elongate them so we can kind of see what's going on. Okay, so if these 2 are parallel, then we have a couple of transversals. So EC is a really nice transversal. So now you have to remember our transversal rules, okay? And in this case, you have angle B here and angle C, okay? These are corresponding angles, right? Because they're in the same place. And what that rule tells us is that if you have parallel lines cut by a transversal, that the corresponding angles are equal. So what you can say is that angle ABE is congruent to angle DCE. Okay? And we've got our 1 and our 2, and they are similar by AA. We can write our similarity statement that says triangle ABE is similar to triangle DCE. And we're done. Okay, so we'll do it on quiz number 1. You remember it. And so we need to draw the relation of ABC, okay, with the given vertices and the scale factor of K. So let's look at 11 first. We have the scale factor of K. So that means we're going to multiply each of the coordinates of A, B, and C, all of these, by -5. Okay. So A prime is going to be 0.5 times -6. It's going to be -3. 0.5 times 6 is 3. Okay, B prime is going to be -6 times 0.5 is -3. And 0.5 times -6 is -3. Okay, C prime is going to be 8 times negative, times, sorry, 0.5. That's going to be equal to 4. And 0 times 0.5 is always going to be 0. So we can draw our figure, and we have negative 3, 3. So negative 1, 2, 3, up 3, 1, 2, 3. And A prime. Okay, B prime is negative 3, negative 3. So negative 1, 2, 3, negative 1, 2, 3. There's B prime. C prime is 4, 0, so x is equal to 4. 1, 2, 3, 4. Okay, C prime. And we can link them all up. Don't forget to link them all up. Okay. So and you can tell, you can just take a quick look at these, and you notice that A is negative 6, positive 6. So 1, 2, 3, 4, 5. It's not even on the board here. And then it's up 6. So it's way out here. Okay, B is way down here someplace. And C is 8, 0, so it's here. So this was our pre-image, something like this. So it was a reduction, okay, and that's what the scale factor says. The scale factor is less than 1, so it's a reduction. And that all makes sense. So you'd always do little checks like that help you make sure that what you've done is correct. Okay? So here we have 1.5. Okay, this is greater than 1, so this is most likely going to be, well, it is going to be an enlargement. Okay. So, A prime, we're going to multiply 4 by 1.5, and that'll give us 6. We're going to multiply negative 2 by 1.5, that's going to give us negative 3. Okay, B prime. 8 by 1.5, 8 and 4 is 12. Okay, negative 2 times 1.5 is negative 3. Okay, C prime. 1.5 times 4 is 6. 1.5 times negative 8 is negative 12. Okay, so these are by 2's, notice. So A prime is 6, 3, so x equals 6. 2, 4, 6. Negative 3, negative 2, negative 1. So that's going to be A prime. Okay, B prime. X is equal to 12. So 2, 4, 6, 8, 10, 12. Negative 3. B prime. C prime is 6. 2, 4, 6, negative 12, negative 2, negative 4, negative 6, negative 8, negative 10, negative 12. Okay, C prime. So now we connect. And C. Sorry about my squiggle line. C to B, A to B. Okay. So let's see if this is an enlargement. I think we can do it here. So A was 4, negative 2. Okay. B was, oh no, yeah, it is an enlargement. B was 8, negative 2, 2, 4, 6, 8, negative 2. And C was 4, 2, 4, negative 8, 2, 4, 6, 8. And sure enough, the image was smaller than the dilation. Okay? So we'll go on to the next video.